So holism is the opposite of reductionism or atomism. Reductionism or atomism is the idea that you can treat nature as just a collection of discrete individual objects. And this reductionism is actually an implicit, sneaky, hidden part of the materialistic paradigm, which we've talked about in the past when we talk about metaphysics and we talk about epistemology. The materialistic paradigm is the idea that the universe is real and it's material, it's out there, it's physical, it's external, it's objective, it doesn't depend upon the mind, and these sorts of ideas. A lot of scientists subscribe to this sort of paradigm. Well, it's not just that. It's also the idea that you can just boil everything down to something like atoms, such that a human is nothing other than just atoms. And the planet is just nothing other than atoms. And that everything ultimately is just physics. And that if we can just figure out physics at the quantum scale or whatever, then we will understand all of the universe, and that's going to be it. And everything else is just some sort of epiphenomena or just some sort of second order, third order, fourth order effect from the molecules bouncing around. It's this kind of idea. And then we tend to approach everything in life that way, and it creates all sorts of problems because this is an unholistic way of thinking. And ultimately, it leads to many dysfunctions and pathologies, as we'll be talking about. So it's this idea that if we want to understand what a frog is, what we do is we go into the swamp where the frog lives, we yank the frog out of there, we put it in a glass terrarium, and then we study it for a few days, and then we throw it into a blender, blend it up, and we study the juice of the frog, and that's the real essence of the frog. To understand the frog, you got to blend it up and study its juices under a microscope. And there you see the little molecules and proteins, and then you break that up even further. You put it into this sort of centrifuge machine that separates all the different cells and molecules into different layers based upon their size and weight and density and so forth. And then that's how you really understand what the frog is. The frog is really carbon atoms and nitrogen atoms and oxygen atoms, and that's what it is. This is a very unholistic approach to doing science. And this is where science creates a lot of problems for itself. You know, people sometimes say, Leo, why are you so anti-science? I'm not anti-science. I'm actually very pro-science. But I want science done in a holistic manner because the spirit of science is to understand reality as a whole, not to understand little bits and pieces. Because the problem is that just because you understand one bit or one piece of reality does not mean that you have the same kind of understanding as the whole of reality. You can't just stitch together a little bit of, someone blended a frog here and someone did something there and someone understood some molecule there, and then we just stitch all those together and then we understand reality. You can't understand reality that way, and if you think you can, that's an implicit part of your epistemology and metaphysics that you're sneaking in, which you did not actually validate or prove. No scientific study has been done to demonstrate that this is the right way to do science, or that this is the only way to do science, or that this is how you get to truth, or the highest understanding. We've discussed this in my series, Deconstructing the Myth of Science, Part 1, 2, 3. Go check that out if you're interested more about the deep epistemology and metaphysics of how science is done and the various corruptions that exist within science. So you see, look at how much is missed when you blend this frog and you only study its juices. What about how the frog lives? What it eats? How it interacts with other frogs? How it relates to the environment that it's a part of? To even think of a frog as this separate, discrete object, separate from the swamp in which it lives, separate from its other members of its species and its mates and its society or community, that already is a deeply reductionistic, unholistic, highly problematic way of understanding a frog. You might think that just by yanking that frog out of its habitat and then studying it inside of a terrarium, that would be better than blending it in a blender. And you're right, that is better. Maybe you play with the frog, you feed the frog, you learn something about the frog that you don't understand by blending it. But even that doesn't really capture the whole of it, because if you really want to understand the frog, you got to go into the swamp where it lives and study its natural habitat, because the frog is going to behave differently in your lab terrarium than it will in its swamp. And it will behave differently depending on what season it is, what time of day it is, how the rainfall is, whether it's mating season or not. And you might say, okay, Leo, fine. I'm gonna spend more money and I'm gonna go into the swamp. I'm gonna set up a little cubby there, camouflaged in the swamp, and I'm gonna study those frogs that way. But even there, you're not understanding the depth of the problem. Because just you being there in the swamp next to the frog, studying the frog, that already influences the frog's behaviors. And you might say, no, but I'm camouflaged, so it can't. See, but you're assuming that the frog has the primary mode of seeing you through its vision. But what if the frog's got other senses that you don't even know about? Maybe it can hear you. Maybe it can smell you. Maybe it's got some sixth or seventh sense that we don't even know. Maybe it can sense your magnetic signature or your infrared radiation or whatever. You don't know. See, you haven't thought about these things very deeply because your whole approach is very reductionistic. And so ultimately, the fatal flaw of most scientists is that they underestimate the entanglement problem. We've talked about that before. The entanglement problem that exists between the scientist and the subject or object that he's studying. See, in a sense, you're entangled with the frog. Your understanding of what the frog is and how you think about the frog, this is all really, it doesn't exist out there in the frog. It exists in your mind, how you think about the frog. Just the fact that you think of it as this separate, isolated creature is already a sort of a category and a projection and a bias that you're imparting upon the thing you're studying. And then you make various kinds of assumptions about whether you can study this frog in a blender or in a terrarium or in the natural environment or however. See? Now, it's understandable why scientists do this, because reductionism makes your life a lot simpler. You can pare down the problem to some convenient little box and then study it within that little box. This makes it easy to do science. But also, it's a sort of a crippled version of science, because your understanding then becomes very compartmentalized and limited too, you see. And so understand that there's different gradations of science. You can have low quality science, you can have very high quality science, but then the higher quality science is more difficult to do. That's why it's not done. Requires a lot more money. It costs a lot more money to go out into the swamp and live with the frogs there. It's not very comfortable and convenient. It's a lot better from a scientist's point of view to study the frog in a lab. But you know what? A lot of the stuff that is studied in labs isn't actually how it works in the real world, which creates blind spots and biases, and it creates bad science.